Hola, mi clase. We are moving on to 7.4. We're going to do factoring of polynomials. Oh, look at this, didn't get changed. I can factor polynomials. So what we're going to do is we are going to find the greatest common factor. Remember, that's the largest most of the time. For us, it's going to be the positive integer and the common variable. So we can actually factor out variables too, not just integers, with a common degree. So they have to have the same degrees, matching degrees, that divides evenly into all the terms. So that might sound like a lot, but basically it is the opposite of multiplying. So we've been distributing, right? Taking one polynomial and multiplying it with another by distributing all the factors. We're actually going to do the opposite. So factoring is like anti-distributing. We're going to make it go back the other direction. So if you can tell, this looks like an answer we were getting for 7.3, right? Now what we're going to do is pull it out and have it be like the problems from 7.3. So it says, what is the greatest common factor, GCF, of the terms? So what we do is we look at the coefficients first. So we've got 12 and 8 and 6, and then we look at what the greatest common factor would be of them. Okay, so you know, like 12, those factors are 1 and 3 and 4 and, oh, I missed 2 and 6 and then 12, right? So those are the factors of 12. So then for like 8, it's 1 and 2 and 4 and 8. And then for 6, it's 1, 2, 3, and 6. And so we're looking for the greatest thing we can pull out. And so if we look, we've got 1, 3, 4, 2, 6, right? We got 1, 2, 4. Well, these match a 4, but this one doesn't have a 4. So it looks like the greatest number that I can factor out of all of them is a 2. Okay, and that's what I want. I want the thing that has in common of all of them. So I'm going to divide, basically what I'm going to do is divide these all by 2. And so 12 divided by 2 is 6, and 8 divided by 2 is 4, and the space is going to make sense, and it's positive. And this is technically negative 6, so it's going to be minus 3. Oops, I didn't leave my space. Hold on, I need my space. All right. Now what we're going to do is look at the x's. And we're going to pull out as many x's as we possibly can. So there's 5 x's here, 4 x's here, 3 x's here. The greatest number I can pull out of all of them is 3x. So in a sense, what we're going to do is divide all of these by x to the third, because that's the greatest number I have in common of all of them. And so remember, if we do quotients of powers, I subtract. So 5 take away 3 is 2, so we're left with x squared here. 4 take away 3 is 1, and then x to the third divided by x to the third is just nothing. It's just 1, so there's none left here. The other way you can think of it is 3 minus 3 is 0. So here is what we have left after we divide, but what we're going to do is take what we divided by and put it on the outside. And if you notice, it now looks like our problems from 7.3. Okay, so that's why it's the opposite of what we were doing for 7.3. 7.3, we would now multiply this with this, with this, with this, with this, with this. And what we're doing is the opposite direction. Okay, so technically the question is, what's the greatest common factor? The greatest common factor, I did a little extra, is 2x to the third, because that was the most of everything that I could divide out. So it says factor out the greatest common factor of the polynomial. So again, we need to look at our factors, and we're only going to look at the coefficients because we're only going to pull out a positive integer, as the definition said. So if we, again, look at 6, it would be 1, 2, 3, and 6. And then for 4, it would be 1, 2, and 4. And for 10, it'd be 1, 2, 5, and 10. So again, our greatest coefficient we can pull out, our greatest common factor there would be 2. So we're going to start there. So then I'm going to look at my variables. So if I look at A, I've got 5, 2, and 4. And remember, we want the greatest number that we can, or the greatest number we can actually take out, and the most we can take out is 2. So I'm going to take out an A to the second, because that'll get rid of as many A's as I can out of there. Okay, so that's the most A's I can take out. And then we're going to look at our D's as well, and we're going to see how many we can take out of there. And so if I look, I've got 2, 2, and 3. And so the common factor we can take out is D to the second. And so the greatest common factor for this situation would then be 2A squared and D to the second. I don't know why I said squared and then to the second, but there it is. All right, so now we're going to actually factor all the way out. So before, I really wasn't supposed to show you what's left in the parentheses and all that, but that's what we're going to do now, is actually factor it out and then find the final answer, okay? So what I can divide out here, right, my common factors of 15, 1, 3, 5, 15, and then my factors of 18, 1, 2, 3, 6, 9, and we can see the greatest number I can divide out is 3. So that's going to go out here. We're going to divide these by 3. Now, if you notice, I don't have any variables I can pull out. There's no common variable, and since there's no common variable, I can't factor out an x of any kind. So the greatest common factor I can even pull out is a 3. So 15 divided by 3 will get me 5. We did not factor out the x squared. And then 18 divided by 3 would get me 6. And so there is our factored answer. Okay, so here's B. So what I'd like you to do is try to pause and figure out if you can at least identify the greatest common factor. Okay, don't forget, greatest common factors are not just coefficients, they're also variables. Like we saw here, we had A's and D's pulled out and x to the third right pulled out here. So why don't you pause and see if you can figure out first what the greatest common factor would be. So the greatest common factor, hopefully you figured it out, is 6y squared. Okay, that's because the greatest number in our coefficients that's a common is 6, and the greatest number of y's I can pull out is 2 of them right here. Okay, so now that I have the greatest common factor, I'm going to divide all of these by 6y to the second. So negative 18 divided by 6, let me put this on the outside, would get me negative 3. And then 4 take away 2 gets me 2, so we have negative 3y to the second. And then we're going to divide. 6 divided by 6 is 1. We can put that, but I'm not going to. And then 3 to take away 2 is 1, so I'm just left with 1y. And then 24 divided by 6 is 4. And y squared divided by y squared, because I'm going to subtract, is 0. And so I have no more y's. And there we go. That would be my factorization of that polynomial. All right, I think it would be a good idea for maybe you to pause and try this next one and see if you can do this next one on your own. 12x to the fourth minus 16x to the third plus 8x squared minus 28x. So go ahead and pause. Let's see if you can do this one and see if you can get the same answer I did. All right. So I first need to find those common factors. Trying to see, I think it's 2. Isn't the greatest common factor 2? Because this is 7 and 4. Oh, nope, it's 4. All right, so I'm going to pull out a 4, and then I'm going to pull out an x. So 12 divided by 4 is 3, and 4 take away 1 would get me x to the third, minus 16 divided by 4 is 4, and x to the third minus 1 would get me x squared. 18 divided by 4 is 2, x squared minus 1 is just x, and then minus 28 divided by 4 is 7, and x minus 1x is nothing x, so there it is. And then I just put a parentheses on the end, and there's my final answer. All right, so try this one too. Push pause, try this one out, and see how it goes. All right, so this factor is in fact 2. And if I look at my x's, I can at least pull out 1. And if I look at my y's, I can again also pull out at least 1. So there's going to be my greatest common factor. And so now that I have that, I can divide. So 2 divided by 2 is 1. X squared minus 1, so 2 minus 1 is just x. And then y minus the 1y, right, because of exponent properties, I'm going to divide, is none. So I'm just left with x there. So 4 divided by 2 is 2. And then 1x, 1 minus, it goes away. Y minus this 1 and 1 goes away, so it's actually done. And then I'm going to go plus 6 divided by 2 is 3. 1 minus 1 is none, and then y squared minus this 1y would get me y. And there it is. There would be my factorization. All right. So here's a story problem. It says Alana, I don't know, is in charge of marketing for travel companies. She's designing a brochure that will have 6 photos. The photos will be arranged on the page in a number of ways. So question for A just says, what is the area? So it says there are 2 main square photos, right here and right here, which have a length of x on each side. It says they're square. So that means this is an x by an x, and this is an x by an x. Now there are 4 narrow photos that are 1 unit by x, and that's for all of them. 1 by x, and 1 by x, and 1 by x. So it says, what's the total? Well, we find the total of these 2 squares. That's going to be 2 times x squared, right? Because area is length times width, so it's x squared. Then we have 4 narrow ones, so it's going to be plus 4 times, well, it's just 1 times x. So it looks like this, 1x. So if I distribute here, I get 2x squared plus distribute here, I get 4x. And technically, it does say it's in inches, so technically we would say inches squared, because area is always squared. Okay, so there's the area. And that's it. That's how you find the area of those shapes. I know it says A, and that's because there's other questions in the book for this, but we're just going to worry about that. Okay? And there it is. So the main thing to remember is that factoring is the inverse or opposite of distributive property, right? So factoring, ooh, can't spell today, is the opposite / inverse of distributing. There we go. That's the main thing you got to remember. It's just the backwards version of distributing. All right, so here's your independent practice. You need to factor that problem out. All right, factor it out. All right, until next time, adios.